Hey everyone, welcome. So today we're going to tackle a huge topic. One of the most, game-changing technologies out there, machine learning. We're going to peel back all the complicated layers and really get to the bottom of it. How do we actually teach a machine to think? And, this whole journey really kicks off with one simple but incredibly powerful question from way back in 1950, asked by the legend himself, Alan Turing. This question, it took the idea from just a philosophical thought experiment and started turning it into a reality. It really sets the stage for everything we're going to talk about today. And for a lot of people, the answer to Turing's big question became crystal clear in 1997. This was the moment. It's when IBM's supercomputer, Deep Blue, beat the reigning world chess champion Garry Kasparov. It was this huge landmark event that basically screamed to the world, hey, machine intelligence, it's not sci-fi anymore, it's here.
All right, so to really wrap our heads around all this, here's the game plan. First up, we'll look at those key moments where machines really outsmarted us humans. Then, and this is the cool part, we're going to look at how we learn, because that's the secret to understanding how we teach machines. After that, we'll see where this tech is popping up in your daily life, and we'll cap it all off by looking at the big, important questions this whole thing raises for our future. Sound good?
Okay, let's kick things off with a quick trip in the time machine. See, the idea of machine learning, it didn't just show up out of nowhere. No way. It's been this really fascinating journey, full of incredible breakthroughs. So, the really crucial thing to notice here is just how fast everything started moving. Think about it. We go from Turing's idea of a learning machine in 1950 to the very first neural network just 7 years later. Then things get quiet for a bit before a huge leap in the 90s with powerful new algorithms. And that's when we get these incredible public showdowns. Deep Blue taking the chess crown, IBM's Watson just dominating on Jeopardy, and maybe the most mind-blowing of all, Google's AlphaGo beating the world's best player at Go, a game that is exponentially more complex than chess. The speed is just incredible.
Okay, so to really get machine learning, the best place to start is, us. The original learning machine, right? The human brain. And it turns out, the way we humans learn is the perfect blueprint for how we teach computers to do the same.
So just think about how we learn as kids. The first way is pretty straightforward. Someone teaches us directly. A parent points up at the sky and says, "That's blue." A teacher shows you on the board that 2 plus 2 is 4. Simple, right? You're learning from an expert who just gives you the right answers. All right, the second way we learn is a little different. It's all about finding patterns for ourselves. So, for example, once a teacher explains what nouns and verbs are, you can look at a totally new sentence and start figuring it out on your own. No one's spoon-feeding you the answer for every single word. You're using what you know to discover the structure yourself. And number 3, the one we've all been through, learning by doing. Think about a toddler learning to walk. There's no instruction manual, right? They just try. They stumble, they fall, they bump into the coffee table. Every little mistake is a new piece of information. And every successful step is like a little reward that reinforces what they just did. It's pure trial and error. Okay, now here is where it all clicks together. This is the really cool part. Those 3 ways that we humans learn, they have direct one-to-one parallels in the world of machine learning. This is the absolute core idea we're going to build on. And boom, here it is. It's a perfect match. Learning from an expert, in the machine world, we call that supervised learning. Finding patterns all on your own, that's unsupervised learning. And that classic trial and error, learning from your mistakes, that's reinforcement learning. These 3 right here, they're the main pillars of modern machine learning. So let's break that down. With supervised learning, we are the expert teacher. We give the machine a massive data set where all the answers are already labeled for it. Think of it like this. We feed it thousands of pictures already labeled cat and thousands of others labeled dog. The machine's entire job is to just figure out the patterns that connect the picture to the right label. And the process itself is pretty straightforward, really. You feed all this labeled data, basically digital flashcards, into the machine. It studies them and builds what we call a predictive model. Then, the cool part. You show it a brand new picture it's never seen before with no label, and it uses that model to make its best guess. Is this a cat or is it a dog? Okay, on to number 2, unsupervised learning. Now, in this case, we throw out the labels. There are none. We just give the machine this big, messy jumble of data and pretty much just say, go find something interesting in there.
It's kind of like dumping a giant box of mixed-up Legos on the floor and asking a kid to sort them, but without telling them to sort by color or shape. They have to figure out the groups on their own.
Yeah, and a classic example of this in action is something called clustering. You can see how the algorithm just sifts through all those scattered data points and starts grouping them together into these neat, distinct clusters. And the key thing to remember is it discovered these groups all by itself. We didn't tell it what to look for.
And that brings us to our third pillar, reinforcement learning. And this one is all about learning from mistakes, just like that baby learning to walk. There's no pre-labeled data here. Instead, you've got an agent, that's our machine, an environment, and a goal. The agent just tries a bunch of different things to reach that goal, and it gets rewarded for good moves and, well, penalized for bad ones. And you can really see that feedback loop right here. Our agent makes a move in the environment. It then gets a response, either a reward or a penalty, which helps it update its strategy for the next try. You let this run millions and millions of times, and eventually it learns the absolute best sequence of actions to get the biggest reward. It's exactly how the baby figures out how to walk without falling over. Okay, so let's just do a super quick recap of the big differences here. Supervised learning, it's all about the task. You give it labeled data to predict something specific. Unsupervised, it's all about the data itself. You give it unlabeled stuff and it finds the hidden patterns. And reinforcement learning, that's all about trial and error. It uses rewards to figure out the best way to do something. So you've got 3 different approaches for 3 very different kinds of problems.
All right, so we've gone through all the theory, but you might be thinking, okay, that's nice, but why does any of this actually matter to me? Well, it matters because this stuff isn't just theory anymore. These systems are already completely woven into the fabric of our everyday lives. I mean, seriously, just think about your day. Your bank sends you a text about a suspicious credit card charge? That's supervised learning at work, trained on mountains of data that was labeled fraud or not fraud. Netflix or Spotify suggests a new show or song you end up loving? That's unsupervised learning, finding patterns in what millions of people like you watch and listen to. And remember Deep Blue and AlphaGo? How did they win? Through reinforcement learning, playing millions of games, learning from the reward of a win and the penalty of a loss. This technology is absolutely everywhere, from your social media feed to the fitness tracker on your wrist.
And that brings us to our final, and honestly maybe the most important part of this whole conversation. Because this technology is getting so incredibly powerful and it's everywhere, we have to stop and think really critically about the kind of future we're building with it. For all the amazing things it can do, the engine that drives machine learning runs on one fuel, data. And a lot of the time, that's our data. The entire point of this technology is to analyze huge amounts of it to find insights, and this creates a natural fundamental tension with our right to privacy. So that leaves us with a final, really big question to think about. These systems are literally designed to learn as much as they possibly can about us to get better at their jobs. But as we move forward into this new world, the most important question we have to answer isn't what machines can learn about us, but what we, as a society, decide they should be allowed to learn. Something to think about. Thanks for joining me.